The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI Conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Next presenter is Charles Hanskat. He's the managing principal of Concrete Engineering Group. Charles is an active voting member of many ACI technical and board committees, including the ACI Certification Program Committee, ACI 301, ACI 350, and ACI 506. He currently serves as the chair of ACI 376. He's a board member of ACI's STC. He's also a board member and the secretary of the American Shotcrete Association and chair of the Sustainability Committee. Charles.
I'm going to introduce, is this mic working? Can you hear me? Introduce the specification that we've done for ACI 350. And basically, actually this works. Why do we have a specification? ACI 350-6 is our code. It's a design code. Code requirements for environmental engineering concrete structures. And who's this really intended for? Who do we write codes for? The engineer, designers. But it's not for contractors. Though there are many attorneys that think that 318 should be read by each and every contractor, that's really not the case. And when you look at 318 and 350, the code is geared towards the designer. So why do we have a specification? It's because we need a document that's specifically intended for the contractor, to give direction to the contractor in their work in trying to implement and build the structure that the engineer designed with the ACI 350 code. So one of the other questions is, why not use 301? If you know 318 is the design code for buildings, we have ACI 301, which is specification for building concrete buildings, basically. And it is intended for structural concrete for buildings. It parallels 318. But 350.5, this is our new specification, but the number is probably going to be 350.5. I can't guarantee it absolutely, but that's the next number that we have in the order of our documents. But it's structural concrete for liquid-containing structures, and it parallels ACI 350. And then once again, why go to the work? We got a lot of work in doing our code, and why take the time and effort to do a specification? It's predominantly because liquid-containing structures are not the same as buildings. We have much higher loads. If you look at a 30-foot head of water on a floor or a wall, 30 foot times 62.4, you're talking almost 2,000 pounds per square foot. I don't think you find that kind of loading situation in a building. It may be point loading, but across the entire structure, probably not. And many of these loads are dynamic loads. You'll find in our environmental structures, sometimes we have very large machinery providing torque, dynamic effects from pumps that are connected through piping to walls and various things. This gives you an idea. This is a water plant, one of the largest water plants in the U.S. at least, and probably the world. And these are large concrete walls, about 35 feet tall here. And we have pipe penetrations regularly through the walls, and obviously connected to pumps to pump that water in and out. And you get a lot of dynamic forces. In some of the treatment tanks for wastewater, you may have large rotors that rotate within the structure and put massive torques. You don't get these in buildings, and that's one of the reasons we have a code for ACI 350. We also have constant exposures to aggressive environments. It's not something where you have a building and you frame it in. It's relatively dry inside the building. Almost all of ours are exposed to liquids and chemicals. It's routine, and even in treatment of water, to have often very aggressive chemicals that are part of the water. And you can look here, this is a treatment tank, and this is some equipment that's used for taking the sediment out. But we may have varied water levels. One of the most aggressive conditions is where you're right at the water-air interface, and it's actually going up and down. Tends to be very aggressive, as well as having the exposure of the water with chemicals in it. And then you move to wastewater with sulfates, industrial chemicals that get into wastewater treatment, even municipal wastewater, generally will handle some level of industrial chemicals. And also in 350, we're extremely sensitive to cracking that affects serviceability. It only takes a 5 mil crack. 5 mils, it's basically a hair width, and very difficult to see unless you're right on top of it looking at the wall. If it's a 5 mil through wall crack, it's probably going to leak. And on top of that, this isn't just, a little small wall, a wading pool. Many of these structures are 10, 20, 30 feet of head. I've seen tanks that have gone as deep as 70 feet, and probably more than that. If you get into some of the clear wells and things that are associated with water and wastewater structures. There's very few owners that would like to have a brand new structure, tank built, and then this is not polished concrete floor. That is standing water as a result of cracking in this wall. That wall was approximately 2 feet thick, full of reinforcing. There were some issues there in terms of the joints and spacing of joints, execution of joints. But this is what we're talking about for serviceability. Cracking is very critical to our structures, and that's why we have a code. And we felt, ACI 350 felt that we needed a specification. So if you've got a project for a liquid-containing structure, that you can reference our specification and get many of the details that are needed to effectively build a structure that will be serviceable for the owner. We have also some special structures that aren't covered by ACI 318 in any way. We deal with membrane floors. These are very high reinforced, thin concrete floors that we address, made to be liquid-type membranes for soils on or slabs on soil that are flexible with the subgrade. Will go with the flow and not leak. We also deal with the presentation before was on circular wrap tanks diaphragm. This is something that we do cover in ACI 350 code, and we need to cover it in our specifications. We also cover Shotcrete. 318 and 301 don't currently. Well, 301 doesn't currently cover Shotcrete. 318 doesn't cover it directly, though I have talked to 318, and they admit that Shotcrete is something that can be used for 318 structures. But we actually have specification requirements for Shotcrete in our new document. This is an example of a circular wrap tank, and why is this not covered by a 318? It's a circular shell, very high level of pre-stressing, circumferentially wrapped pre-stressing. Wrapped pre-stressing doesn't happen anywhere outside in buildings that I'm aware of. We also have a lot of structures that use domes. 318 does have a shells provision, but honestly, it's probably not been updated significantly in the last 30 years, where we've been maintaining and keeping our code requirements for domes up to date. This is an example of the pre-stress, and you saw that before too. And Shotcrete, which Shotcrete is really not that unusual. It's a placement system for concrete. It's a way to place concrete without any formwork. And that's why it works so well on some of the circular pre-stressed tanks, because they're exposed, the surface is easy to get at. So let's compare 350.5, our new specification, to 301. We have a very similar layout, organization, the three-part format of a specification. In 350, we have greater cover requirements. Why do we do that? Because we have more severe exposures. We also have a lot of attention to the long-term corrosion resistance of the structure. And 350, generally you'll find the covers are increased over what you would have in a building structure. We also have enhanced material requirements for the exposures. When you look at supplemental cementitious materials that might be used, levels of cementitious material required for various exposure conditions. We're very specific. Probably you'll find we're a little bit more conservative than what you'll get in ACI 301. And we cover shotcrete. Once again, shotcrete is a way of placing concrete, but because the placement process involves conveying through a hose, hydration at the nozzle, dry mix, pump that's basically ready mix coming through wet mix. There are some things that are different than regular cast concrete that we need to address, and we've included that in our specification. We also, in 350, require more pre-stress reinforcement protection than you would typically find in buildings. We require all of our unbonded is fully encapsulated post-tensioning systems. We also have some tightness requirements on the sheathing. And then we also have a section on wrap pre-stressing, because if you pre-stress by wrapping a high-strength wire around the tank, that's really not covered by anything that you look at in a 301, 318. And we include membrane floors. One of the things we don't include in the new 301, you'll find industrial floors. That's not something that we're covering in our document. We do touch on architectural concrete because some of our structures are made to look pretty. But we have added membrane floors and excluded industrial floors. So I really want to point out the specification is for the contractor. The specification can be referred to, and this is actually a quote out of the spec. It cannot and does not address responsibilities for any project participant. It doesn't address the testing lab, it doesn't address the owner, it doesn't address the consulting engineer, the inspector. Basically, it's for the contractor. All the provisions, as you read through a spec, should be for the contractor. And then some of you, how many of you have used specs like 301? So we have some people, you know, there's a checklist, right? So what's a checklist? Well, yeah, we do have a checklist, but that is really not a part of the specification. If you look at the wording that we have, we say this is for guidance to the specifier that helps the specifier identify items. We kind of flag those items that they need to look at when they're developing their project, their specific project specification. We have mandatory checklists. This includes what we say here: work requirements, specific qualities, procedures, materials, performance criteria that are not defined in ACI 350.5. We don't provide a default value. We don't provide really anything. We're saying you as a specifier have to go through all these mandatory items and select what's appropriate for your particular project. So there's a little bit of homework with mandatory. You have to include it in your project specification. That's something that has to be tailored to the particular project. We then have the optional checklist items. These are basically the same idea. We may give you a default value of a property that needs to be provided, or a process that's going to be provided by the contractor. But we also, there may be some options that should be considered by the engineer. They don't have to be. You can use the default, and the contractor will go their merry way and the project will probably be successful. But we want to raise this flag. Hey, you know, it's something you might want to think about when you're writing your project specification. But once again, I'd encourage you to review each of the items, even the optional items, for your particular project and your project specification. It's not something that you can just say, reference ACI 350.5 and everything's covered. You got to do your homework to get it into your contract documents properly for the contractor to use. When can we get one? I just got an email today that ACI staff said that probably by the end of the year, to answer the big question. But in 350, we've completed our committee balloting. We went through TAC review, went through public review, we responded to public comments. We obviously responded to TAC comments. They don't let you do anything in ACI with doing that. And now I would have expected, based on the email I got today, that it was approved by the Standards Board, and that they will then take our document, put it into the publication department for formatting, and we'll get proofs. And I said by the end of 2000, I was being a little pessimistic, early 2013, but easily within 6 months, this will be out on the street, available for use. And that's the end of the talk. Are there any questions?
How close this code is with the Army Corps of Engineers hydraulic structure?
This is not a code, this is a specification. I'm not that familiar with the Corps of Engineers hydraulic structures, though our expertise on the committee pulls in designers that have been involved in liquid containing structures for 2 or 3 decades. So I would have to imagine that we have some alignment there, but I can't tell you specifically.
Would this specification also be useful for existing structures or liquid containing structures for spill prevention?
With what kind of prevention?
For spill prevention for oil containing equipment?
Sure. Liquid containing structures, the design. There are instances when you have a building that might be exposed. Let's say you have a building that's going to be at a dry dock. It might be partially flooded periodically. You really don't need it most of the time, but sometimes you do. You want an extra level of durability and protection of your corrosion, protection of your reinforcement against corrosion. In your structure, you can use the provisions of ACI 350. There's nothing to prevent you from doing that. And what that will get you, you'll have crack control. You'll be able to say you'll get smaller cracks. You'll get longer life of your structure, and it will be more resistant to some of those. In terms of repair, it could be done. We don't necessarily specify repair materials. So the materials may have to be the judgment of the engineer in terms of what you want to do in your specification. But the basic principles in terms of process, if you're shotcreting or casting, a form and pour type of repair, many of the provisions could still be worked. It would take some judgment probably to do that. Any other questions?
I have 2 questions. Firstly, does your specification, what do you call it, provide the contractor with an idea of how to, or guidelines on how to estimate cracks, how much crack repairs on these kind of structures? And then secondly, is that we also deal with the payment of such crack repairs?
Well, no, we don't deal with that. And one of the things that I find in evaluation of liquid containing structures is the design is very key to the actual cracking that you experience in the structure. If you have a long wall that's, say, 300-foot long, and you don't put any contraction joints in it, I can guarantee you there's going to be cracks. And whatever contraction you got is going to have cracking that's going to be in that structure. So it's tied in with design as well as construction performance. We're dealing in the specification with what's required by the contractor to do a reasonably good job to meet the design that was done by ACI 350 code. In terms of payment, no, we don't get involved in any of the payment issues. That's something that has to be taken care of in your contract documents. you more than likely have to say, this is what we will do for acceptance. I do find in specifications there are times I'll see any cracks will be repaired. And if you have a 2 mil crack, you could be chasing those forever in a structure. I mean, you have to, when you write your specification, think of what's a reasonable crack size or maybe number of cracks of a particular size that's going to still allow acceptance of a structure. You can have some cracking and really not have long-term corrosion or substantial leakage issues. You don't want to have the one like the picture I showed you, which was a little bit of a pond on the floor. Any other questions? I probably took too much time. I appreciate your attention, and Reza, I'll let you go on to the next.